After discussing what is the relation, what is the total number of relations over a set, and how many types of relations we have: void relation, identity relation, universal relation, reflexive, symmetric, transitive, and equivalence relation. I want to share with you one example where you will get to know that how the relation is equivalence or not. As you have been made clear that if a relation holds true for reflexive, symmetric, and transitive. If a relation is reflexive, symmetric, and transitive, it is equivalence relation. So I am taking an example. You have to try to understand. Prove that the set of parallel lines in a plane is an equivalence relation. If 2, 3, 4, as many parallel lines are given in a plane. If I take here few parallel lines, like this is L1, this line is L2, this line is L3. L1, L2, L3 and so on. There may be n number of parallel lines in a plane. The name of the relation is parallel to. In plane, if I take L1, L2, L3 and so on, there are n number of parallel lines. Now, I want to show that this set of parallel lines in the plane is what type of relation is an equivalence relation. To prove this name relation parallel to is equivalence for the given parallel lines in a plane, I have to show it is reflexive, it is symmetric, it is transitive. To prove it is reflexive, you know that each line is parallel to itself. So relation is related to itself. Similarly, L2 is parallel to L2, L3 is parallel to L3 and so on. So what we conclude, the name of the relation parallel to for the set of parallel lines in a plane is reflexive. Second, symmetric. If we talk about the symmetric relation, we know that if Ram is brother of Shyam, then obviously Shyam is brother of Ram. This is what? This is the relation known as the symmetric. Suppose Ram is brother of Gita, but if you change their position, Gita is not brother of Ram. So ultimately what is coming? If by changing, swapping the elements, if relation remains true, then it is symmetric, otherwise it is not symmetric. So what we say for the relation parallel to, if L1 is parallel to, it will be true that L2 will be parallel to L1 for each set of parallel lines. This is true. So we say the relation parallel to for the set of parallel lines in a plane is symmetric also. Third, we talk about the transitive. What is the transitive relation? If we talk about the transitive relation, if we say that A is brother of B, B is brother of C, and all three are male, ultimately we can say A is brother of C. Or Ajay is friend of Vijay, Vijay is friend of Rohit, we can say the Ajay is friend of Rohit. So if line L1 is parallel to L2, L2 is parallel to L3, what we can conclude, L1 is parallel to L3. So this relation is transitive also. So as the relation is reflexive, symmetric and transitive, so what conclusion is coming? The conclusion is that given relation of parallel lines is equivalence relation, hence proved.